Hello everyone, welcome back. In this video, we're going to talk about measures of the center of data. So there's a few different ways we can conceptualize what the center of a set of data is, and we're going to start by talking about the arithmetic mean, which is also just referred to as the mean or the average. And so what is this quantity that is the arithmetic mean, or just the mean or the average of a set of data? Well, the mean or the average is the value that we could replace all the data points with, such that if we summed up all the data, we would get the same sum. And so we always calculate these arithmetic means or averages in the same way, and then we add up all of our data values and then divide them by the number of points in our data set. However, there's a little bit of special notation that goes along with the idea of a mean or an average, depending on if you're working with a population or a sample within that population. So if we're talking about a population mean or a population average, that'll be denoted by this Greek letter mu. And like we said before, the way we calculate mu or one of these arithmetic means is we add up all the data values. In this case, we're assuming that our data set has capital N values. So we add up all those data values, x1, x2, x3, up to our last data point at xn, and then we divide by capital N the total number of points in our set of data. And if you haven't seen this sigma or summation notation before, that is just our shorthand notation of saying that we're taking the sum of a bunch of different values. So the way this summation notation works is we have this capital Greek letter here, this capital sigma. It looks kind of like a big E. Below that, we have some subscripts, as well as at the top, we have a superscript. And what these kind of values are telling us are where we start and end our sum at. And so that little I equals 1 says we start by taking the first value in our list of data. In this case, that would correspond to x1, right? If we set I equal to 1 in our little formula here, we would get x1. That's the first term in our sum. We then add on the second term in our sum by replacing I with the next integer value, which would be 2. And we keep doing that, adding on more terms in our sum until we get to this number at the top of our notation. That tells us our stopping point, which in this case is capital N. So this summation notation is used throughout mathematics in a lot of different ways, but for us, it's going to be pretty standard. We're just adding up a bunch of data values. And so oftentimes you'll see some of these index notations left out or omitted. You'll see something like this, like the sigma of x, and we should know that we're adding up a bunch of x values when we see that set of symbols. So another type of mean or average that we end up looking at quite often is a sample mean or a sample average. That's denoted differently than the population mean or population average. Our sample mean or sample average is denoted by x bar or x over bar. And so here, we're just assuming that the sample of our population has fewer data points than capital N. We're saying it has a lowercase n number of data points in our sample. But it's calculated in the same way. We add up the data points in our sample, all those x values 1 through little n, and then we divide by the number of data points in our data set, in this case, little n. And what we always hope to have happen is if the sample we are taking of our population is actually a good representation of the population, then we should have that the sample mean is approximately the same as the population mean. They shouldn't be too far apart if the sample is actually representing the population very well. All right, so before we look at some examples of calculating some means or averages, let's go ahead and define our other concepts for measuring the center of data, the median and the mode. All right, so up next, we want to talk about the median, which is another way to measure the center of a set of data. And the median is defined as the value that half the data points are above and that half the data points are below. So one way to find the median is to order all the data, write it in order from least to greatest or from greatest to least, and then find the value that is directly in the middle. And a shortcut that'll help us do that, which is very useful, especially when we're working with very large data sets, is the median is always given by the n plus first over 2 data point. So we're going to have n data points in our sample. We take one more than that number n, that's n plus 1, divide that by 2, and that'll give us the location of the median within our data set. The one thing we have to be a little bit careful of and note for with the median is what happens in some cases if our data is not an odd number of data points is we have to take an average to actually find the median. So let me go ahead and show you what I mean by that. So let's go ahead and look at some really small examples just to wrap our heads around this idea. And so what happens if our data set contains an odd number of data points, like say 3? Then we have x1, which is smaller than x2, which is maybe smaller than x3. So we have our data written in order. And in this case, well, it's obvious that the middle data point is x2. Just take out those n data points, and what's in the middle is x2. And so here n is equal to 3. And so if we look at n plus 1 over 2, well, that's equal to 3 plus 1 over 2, which is 4 over 2, which is 2. So that's our way of telling us that the second data point, x2, is going to be the median. But we have to be a little bit more careful when we're working with a data set that has an even number of data points, right? Here we have an odd number of data points. So if we have, say, 4 data points, x1, x2, x3, and x4, well then the middle is like right in between x2 and x3. There is no data point that actually corresponds to being in between x2 and x3. So what we do in that case is we say that the median is going to be the average or the midpoint between those middlemost values of, in this case, x2 and x3. So in this case, the median is given by x2 plus x3 divided by 2, find that middle point or that average between those middlemost values. And also, if we use our little formula over here, what is the n plus first over 2 data point? Well, here n is equal to 4. And so if we plug that into our little formula, n plus 1 over 2 is going to give us 4 plus 1 over 2, which is 5 over 2, or 2.5. So right in between that second and third data point is where our median is going to lie. And so we have to find the average between that second and third data point to find the median. Right, so the last measure of the center of data that we want to discuss is the concept of the mode. So the mode is really simple. It's just the value that shows up the most frequently in our set of data. So we really just look at the frequency table for our set of data and find that largest value of n. And so what can sometimes happen is there can be a tie. So if we have 2 values that share this property of showing up most frequently within a data set, then we say that our data set is bimodal, and we would list both of those values or numbers as being the mode. If more than 2 data points share that maximum frequency property, then we say that our data set is multimodal. However, if every value in our data set has the same frequency, then we say there is no mode. And so we'll have no mode when every value shows up exactly once, or if every value shows up exactly twice, or every value shows up the exact same number of times. All right, everyone, let's go ahead and recap these really central ideas for measuring the center of a set of data before we look at an example of finding them. And so the mean, remember, is just the average. And the way we find that is we add up all of our data values and then divide by the number of data values. And we're going to use the mean, or the mean is a good measure of the center of the data when the data's frequency is distributed roughly symmetrically. So that means if we visualize our data using like a histogram or something like that, then it's kind of symmetric about some line right in the middle. So the median is another way we can measure the center of our data, and that is the middlemost x value or the middlemost data value in our set of data. And that is always given by the n plus first over 2 data point when we line them up in order from x1 being the smallest to xn being the largest. Then also remember, we have to be a little bit careful when we're working with an even number of data values when we're calculating the median. We always find that average between those middlemost values. And so the median is really useful and is a better measure of the center of our data than the mean when our data is going to be skewed either farther to the left or farther to the right when we visualize our data set. And so the last way we can think about measuring the center of our set of data is the mode, and that is simply just the most frequent value that shows up in our data set. And remember, sometimes there can be a tie for first place, so we can have 2 or more modes. So the mode is a good way to measure the center of our set of data when our data is qualitative in nature, right? In order to find something like the mean or the median, it requires quantitative data that we can actually make sense to add together. But that is not the case for the mode. So when our data is qualitative, the mode is a good way to go. Or if what we're looking for is that most frequent data value, that is the mode. So it makes sense to go and find it. Right? If your survey is asking what is everyone's favorite color, it's hard to find like an average or a median for people's favorite colors because they're not quantitative values. However, you can find the mode of that data set, which would represent the color that people chose most often as their favorite. All right, let's go ahead and calculate these different measures of the center of data, looking at this example here. And so in this example, we're told a student's 10 quiz scores are going to be given below, and we just want to find the mean, the median, and the mode of the student's quiz scores. And so here we have our data set already written in a nice ordered way for us. Sometimes we have to do the ordering ourselves or have technology assist us in that ordering. But for calculating the mean, the ordering doesn't really matter. all we have to do to calculate the mean is add up these 10 values, then divide by the number of values, which is 10. So let me go ahead and write those steps on the board, and we'll figure out what the mean is together. All right, so here I'm doing our calculation for the mean. We're just adding up our 10 quiz scores and then dividing by the number of quiz scores, which is 10. And if we do all this arithmetic, what we find is that the mean is going to be 82.6. And another note that is worth making is that when we're working with finding the mean, we're often going to have to round some values. And so our rule of thumb is we're going to round to one more decimal place than what shows up in our set of data. So in this case, all of the values in our set of data were nice whole numbers. So that means we're going to round to one more decimal place or just one decimal place. That's why we're saying the mean is 82.6 and not rounding up to like 83. So always just add one extra decimal place when you're finding the mean. All right, up next, let's go ahead and calculate the median. And so remember, the median is just our middlemost data value. And so in order to find the median by hand, it does require us to list our data set out in order from least to greatest, and that is already done for us in this example, but we shouldn't always assume that our data is always given to us in the ordered form. And so now we could just kind of count our way down to the middle to find the median that way, or we could use this little shortcut that the median is always given by the n plus first over 2 data value. And so let's see, we have 10 data values in our set of data here. So the median is going to be given by that 10 plus 1 over 2 data point. But that's like 11 over 2 or 5.5. And so we really don't have a data point corresponding to 5.5. So we have to remember how to interpret this. This is telling us we have to take the average between the 5th data point and the 6th data point. So what is our 5th data point? Well, it's 1, 2, 3, 4, 5. That's 78. And so our 6th data point, since they're written in order, x6 is going to be 81. And so to find the median, we just find the average between these two values or the midpoint between them. So that's 78 plus 81 divided by 2. And if we calculate that out, we should get a value of 79.5. And so the median of our data set here is 79.5. That means half of the students' quiz scores were below 79.5, and half of the students' quiz scores were also above 79.5. And we can also see is that the mean and the median in this case really aren't too far apart. All right, so we have one more measurement to go with a set of data, and that is the mode. And that's going to be pretty quick and easy to find here. We just have to look at the frequency of all of our data points and see which one has that maximum frequency or shows up the most. It looks like most of our data values are showing up just once. However, this value of 78 shows up twice, and the value of 100 also shows up twice. So there is a tie for first place in the maximum frequency of our data values. So in this case, our data set is bimodal, meaning we have two modes, and those modes are 78 and 100. Okay, so we do need to know how to calculate the mean, the median, and the mode by hand, but oftentimes in practice, we'll be working with very large data sets where it's not practical to do so. So we need to be able to know how to use technology to assist us as well. So I want to show us a couple different ways we can use technology to find the mean, the median, and the mode. And first, we're going to talk about how to find it using our graphing calculators. Okay, so if we want to calculate the mean, the median, and the mode using our graphing calculators, well then we first have to enter our data into our calculators. So to do that, make sure your calculator is on, and then you're going to want to hit that stat button on your graphing calculator. Okay, so when you hit that stat button, you'll be brought into a new menu, and the first thing you'll see in that new menu is edit. And so it kind of defaults you to where we need to go. So we want to hit edit within edit. So usually just 1 or enter as soon as you get to that edit screen. And what this is going to do is bring up your list of tables that you can enter your data into your graphing calculator. And these tables are commonly labeled as L1, L2, L3, and so on, basically for like list 1, list 2, list 3, and so on. You may have some data in your table from previous calculator use. If that is the case, then you can just scroll to the very top using the arrow keys and highlight your list. In this case, I'm highlighting L1. Then if I hit that clear button and then hit enter, it'll clear whatever data was in list 1. And now I can start entering my new data in. And so let's go ahead and enter these data values in, hit 65, hit enter to enter in 65, then go to the next line and type in 70. And we're going to do this for all of our data points. Okay, so we now have our 10 data points entered into L1. And so what we're going to do next is hit that stat button again to go back out to that main menu, but we don't want to be on the edit screen anymore. Now we want to go over to the calculate screen. And to do that, you're going to use that right arrow key on your calculator, hit it once, and that'll navigate over to the calculate menu. And that very first option you should see on your graphing calculator should be 1var stats, short for one variable stats. Highlight that and hit enter. And so depending on how recently your graphing calculator was made, it may just bring you back out to your screen where you can hit enter and it'll default using list 1 or L1 as the list it does this number crunching with. And if for some reason we stored our data in a list other than L1 or a table other than L1, then what we can do is type a left parentheses and then hit second and 2, and that'd take us to L2 or enter in L2. Or if you hit second and 3, that would be L3 and so on. Then doing a right parentheses to kind of end that function type notation and hitting enter will calculate your one variable stats or 1var stats. But maybe your graphing calculator doesn't look quite like that. Maybe it just says something like list or frequency list. In that case, your list might have L1 as a default, but if it doesn't, you can just hit second and then 1 to call up L1 on your calculator, then scroll down to calculate and hit enter, or if you don't see that calculate, just hit enter after you see 1var stats. And now this should bring you to a screen where you can recognize some of these symbols already. At the very top, we see X bar, which is our mean or average. And what does our calculator say? Well, it also says that our mean is going to be 82.6. There's some other stats that we'll learn about later on the screen, but if we scroll down using that down arrow key, we'll next find the median. And here we can see that the median is 79.5, just like we calculated by hand. And so that's a quick little overview of how we can use our calculators and the statistics package within our graphing calculators to calculate the mean and the median. The mode we still have to do ourselves. Okay, so I also want to show you how to use some other software to calculate things like the mean, the median, and the mode. And so for this video, in this example, we're going to see how to do this in Google Sheets. And so the first thing we need to have is all of our data entered into a Google Sheets document, which I have here. It doesn't need to be formatted this nicely. Really just need that raw data in your Google Sheets. So here we have it entered in to this column A. And so now I want to calculate the mean or the average of this set of data. And so here I'm going to do that in the cell D4. So I highlight the cell that I want to calculate the mean or the average in. And then what I need to do is first hit an equal sign. And that's letting the software know that we're about to do a calculation or have the software do a calculation using the data in our spreadsheet. And so now we want to type in after that equal sign is average. And oftentimes it'll kind of autofill for you. So type in average and then hit enter or type in the rest of it. And then it'll start by a left parentheses. And what has to follow after that left parentheses is the range of the data that you want to find the mean for. So you can type that in by hand by finding that first cell that your data point is in. In this case, that's A2. And then if you hit a colon and the final data point, in this case A11, it'll find the average between all those values in that column from A2 to A11. If you have your data spread out through multiple columns, you have to do this for each column and then separate those columns by a parentheses. But another way to do it that is much, much quicker than typing it in by hand is just dragging, or left clicking and dragging, I should say. So click that first cell where our data is in, and then carefully drag down to the last cell and then let go of your left click, and that types in A2 through A11 for us without having to know all of the syntax. And that'll calculate your average or your mean for that set of data, which, what do you know, we see it as once again 82.6. And what's really nice about doing this in something like Google Sheets or Excel or some of these other computer software packages is now if we go back and edit our data, it'll automatically recalculate the mean, the median, and all these measures. Whereas if we did it by hand or on the graphing calculator, every time we go back and change the data, we got to recalculate these quantities. Okay, so how do we find the median? Well, you can probably guess it. Hit equal sign, and as to let it know we're about to do some calculation with our data, and then start typing in median, and let it autofill or finish typing it in yourself. And then you have to, do that parentheses kind of function notation again. And here we're going to input that range of data, which is exactly the same as before, A2 through A11. Right end parentheses and hit enter. and it calculates our median as 79.5, just like how we got by hand and with our graphing calculator. Okay, so our graphing calculator wasn't able to find the mode, but Google Sheets will. So once again, we hit that equal sign to let it know we're about to enter in a formula or use our data points in some formula. And now we want to start typing in mode, but we have to be careful here because you'll see that there are a couple different options once we type in mode. So if we just do that first option for mode, it'll only actually give us the first data value that shows up most commonly. So if we have a bimodal data set or a multimodal data set, then this isn't the function we want to use. So we want to scroll down and just use mode.molt. And so mode.molt will return all the values for the mode if we have a tie for first place in frequency, like we know we do with this data set. So we type mode.molt and then enter in our range of data values and that parentheses to let it know we've entered in all of our data values, hit enter, and here it'll do it in 2 cells, but we see that we have 2 modes of 78 and 100, just like what we found when we analyzed the data by hand. All right, so now we've seen how to calculate these measures by hand using a graphing calculator or some computer software. So you may end up using like Excel instead of Google Sheets, but the syntax is going to be very, very similar.